So today we're going to look at Tetris, written in Bash. Yes, that's correct. It's going to be Tetris. It's running on your terminal. It's written in Bash, and it is super cool. It's really awesome. I checked it out a little bit, but I wanted to save some of the fun stuff for a video because I have some ideas with it. Now, we are not going to write this. I did not write this. It's already written, and it was written by friend of the channel, Badcop. As you know, she's wild. She writes a lot of really fun Bash. We've collabed in the past. We definitely have to do more collabs in the future. Her ideas are just super fun. She approaches Bash way differently than I do, but it's still like same kind of like energy, and I just love it. Oh man. So we're gonna have a ton of fun looking through this. I want to show you guys it today, and I want to like break into how it works and some of the concepts behind it because I think it'll be a ton of fun and I'm excited. Tetris is a game I really like. Actually, I'm more of a fan of Dr. Mario for the regular Nintendo, but Tetris is a game that I like and respect a lot. I love watching like the classic Tetris, like World Champions and stuff. Like it's so much fun to watch people play it. The high level Tetris play is crazy. Just watching people go from dash to hyper tapping to rolling. Now, if you don't know what I mean, I can link a video where it explains all this. I can't, someone else is explaining it. It's a ton of fun. So yeah, I'm excited to look at it because I don't know how I would implement this. I've never written Tetris before, so I wouldn't even know how to approach this. So we're gonna have a ton of fun looking at this. So yeah, let's dive in. So here's the GitHub page for it. I will have it linked below in classic Badcop fashion. There is one commit, there is no README, and there is one file, and that is it. It is just the bash file, and I'm sure we are gonna see no comments here. Let's not even spoil this. Let's just go clone this to my local repository. All right, so we'll do a simple git clone. I'm gonna paste that in from my clipboard, and we have Tetris, which I assume is bash Tetris. CD into Tetris, and as we know, there is one file here. It is a born again shell script, a bash script. So let's take a look at the source code before we do any work here, before we run it. So as we can see right here, okay, we fork out to clear, we fork out to tput, so there will be some external commands. I've gone over the clear command and tput and tset and reset and all that fun stuff in a previous video. If you want to go check it out, it's a super deep dive. You could have also used this, and this would totally work just the same, and you would limit yourself to one less executable. But this is totally fine. I didn't come here to critique this code. I came here just to look at it. So yeah. So we have a hard-coded, I'm going to assume width of 10 and height of 20, and the max is the width times the height minus 1. I don't know what that's used for yet, but we're going to find out. Oh man, I don't mean to spoil anything, but are we just going to keep a two-dimensional grid of every possible thing and the max is minus 1 because that's the max possible element before you go above it? It might be. So then we call clear. This clears the screen. We call tput civvies. This is the opposite of tput c norm. This turns your cursor invisible. This restores your cursor. So we're hiding the cursor here, which is super nice. We're creating an indexed array called grid, and indexed array means that the keys are numbers. And then we are creating another array here. This is an indexed array of strings. Now this looks super weird. This is one string. This is two strings. So this is element 0. This is element 1. This is element 2. Look at this. These are all the Tetris pieces. Tetraminos? I think they're called tetraminos. Let me go do some research. Grok, what is a Tetris piece called? I just Googled tetramino, so like that's actually the is this the opposite of research? Oh my god, light mode jump scare. 3, 2, 1. Dude, Wikipedia is so like look at this. I'm gonna turn my computer screen down. That is wild. Oh my goodness. All right. Tetramino is a geometric shape composed of 4 squares connected orthogonally. Beautiful. The 5 free tetraminos. A snapshot from a typical game of Tetris. So yeah, somehow that was just in my brain. That's awesome. Okay, let me turn the screen back up now. Wow, changing the screen brightness really affects how light I am. That's crazy. So if you're, wow, okay, cool. I don't know what to do with that information, but yeah. All right, so we have all our tetraminos here. That's super cool. These are all the possible pieces. Now we have a render function. I'm gonna skip the functions for now. We have a nice little indexed array tucked neatly between functions, so that'll be hard to find. I can critique this script a little bit, right? Badcop's my friend. I think I can get away with that. Okay, let's scroll down. Let's skip the functions for now. Try rotate left, try rotate right, rotate left, rotate right. All right, beautiful. Set, that's crazy. Set is a bash built in. So yeah, it's a shell built in, so you're just overriding the shell built in. Nothing wrong with that if you're just never calling set. That's totally fine. You can override these all you want. It's just so funny. I'm totally gonna see set used later in the code and be confused, but we're good. PX, PY, I'm guessing this is the pieces X and the pieces Y, probably the current moving pieces. I'm totally guessing here. And then we have a next function. What else do we have? Next equals fall, all caps. So just global namespace here. Place function. Oh boy, there's a lot going on here. A try place function. Okay, we have try rotate rotate, try place place. We have an unplace, That's super interesting. Do you try to play something place, then unplace if it fails? I'm curious how this works. Test dir. Test direction. Okay, I'm thinking like directory, like, folder or something. I'm like, what do you have to test here? Oh, this is cool, Badcop. I'm glad that you do this too, where you return $? Explicitly. You technically don't need to do that. Causes a function or source script to exit with the return value specified by n. If n is omitted, the return status is that of the last command executed within the function or script. So technically speaking, you do not need this. It will just return what try piece returns, but I like this. It's very explicit. It makes it very clear what my intent as the programmer is. So I'm a big fan of that. And we have our game loop function. Okay. And input task, tick task. Okay. I'm at the bottom of the script now. We can finally start figuring out what's going on here. So, okay, we use this file called /temp/gameloop. If it's not a pipe, then we will create it. So if it's not a pipe here, we'll run make FIFO temp game loop. So this will create a pipe. This is a named pipe. I have videos where I talk about named pipes. They're super fun. They're super cool. They're not specific to Bash. Any programming language can use them. Anything on your system can use them. You can have interoperability between different programming languages. Super cool. You fork the input task in the background. That's what this ampersand is doing. Let's not look at the redirections yet. You fork the tick task in the background, and then you block on the game loop. Okay, so let's take a look at this. We have two tasks, two programs being forked in the background, and they have a greater than game loop. So both of these things are writing to the pipe, and the game loop is reading from that one pipe. This is a common thing I've seen. I've done this with my own whoami music player that I wrote before. So basically, the beautiful thing, if you've ever done any sort of like UI programming, you're probably used to this. You can do things in the background, but when it comes time to do your game loop or the thing that needs to actually render the UI, it needs to happen in like the main thread of execution. So the game loop, as I'm going to consider the main thread here, it's not technically threads, they're different processes, but like this is our main thread here. We have an input task, which reads from dev tty, which is our terminal. So that's going to take the user's input. I can already figure that out. And our tick task. So let's take a look at what these things do independently. So we have our input task and our tick task. Luckily, they're very small. Look, they're defined right here. Input tasks reads one character from its input. This is this function standard input. And you can see our standard in is redirected here. So it's reading one piece of input from the terminal directly. It's reading one character, SN1. So S is for silent, I think, and N1 is one character. So if I do a help read -S, do not echo incoming input coming from a terminal, -n chars. So yep, that's exactly what's going on here. We're silently reading one character, and then we're echoing this text. We're echoing this text to the pipe. Input space the character that was read. Cool. Now look at our tick task. So our tick task, that's really hard to say, is an infinite while loop, sleeps for half a second. So we do fork out to an external sleep command. Not a big deal. You can expect this to be on your system, but technically fractional sleeps are not POSIX compliant. I don't think Badcop's going for POSIX compliance here, so that's not a big deal. I'm just pointing that out because it's fun to point out. And then she echoes tick here. So we have a very basic, I can already see this. This is a text-based interface. This is happening internally. We're not going to see any of this as the player of the game, but we're going to emit the input and then what the user press on their keyboard. And then we're going to emit just the word tick. And I'm willing to bet the game loop is going to go in an infinite loop of reading that pipe line by line and looking for input and looking for ticks. So looking for ticks, that sounds so stupid. Anyways, let's go to the game loop. Okay. So piece, we will take random mod 7. Where does 7 come from? Oh, is that how many tetraminos there are? Hold on. Let's go up to here to our array of tetraminos. 1, 2, 3, 4, 5, 6, 7. Okay, cool. So there are 7 here. That's fine. I mean, you just hard code it there. You could get the length out of it. You could do like, I mean, Badcop already knows this, but you could do like T like this and then put this in front of it to get the length. I mean, it's fine, whatever. So we have 7 here. So you make a new tetramino from a random piece. So we randomly get a drop. That's cool. And then you place it here. This is px plus py times w. I know what's happening here. Let me go up to the top of the script. We have our w and our h. We have our px and our py. We also have a w variable at the top of 10. So I don't know if you guys can figure out what's going on from this. Each piece will have a px and a py. That is probably where the piece currently is. Look at its position. So we have our py times the width plus the px. That's because Bash does not have two-dimensional arrays. So what Badcop is doing here is very clever. She is abusing indexed arrays. It's a one-dimensional array of our grid. And to calculate that, you take one of the directions, so either left or right, you multiply it by the width, and then you add the other direction. So basically, if you have, let's say, a 10 by 20 grid, 10 times 20 is 200. You have 200 possible places. This array will have 0 through 199. So every single place will be accounted for in an index array. It's a cool little trick. It's super useful if you're in a language that doesn't have nested arrays. Nested arrays would make this so much easier to understand, but we don't have those here. So we do this. We place it at wherever its current PX and PY is. Now, I believe those were initialized. Okay, they were just set to 4 and 0. 4 probably puts it right in the middle of the map, and PY puts it all the way at the top. So we're going Y. As Y goes up, we go down the screen. That makes sense. That's kind of how the terminal draws too. So that's super cool. Then we will render the screen, and then look at this. While read-R, action, and character. So if you remember our action, oh, look at this. We do a case over it. Our action could be tick, or our action could be input, because those are the two tasks running in the background. If our action is input, then we do these little checks here. Oh, I see why you didn't use a case statement. Look at this. You have compound if statements. That's why you didn't use a case here, because you also have to check this. Yeah, if statement's totally fine. Like, of course, it's totally fine. Obviously, I'm assuming this works, but like, I can understand why you would go with this approach. That makes perfect sense. So first thing we do, call render. Let's take a look at that. Let's figure out what the render function actually does. We loop over the height, we loop over the width, we are looping over the grid character by character. You are extracting the color that's stored in the grid and defaulting it to 0. So the grid, I mean, remember, it's a one-dimensional array, but it represents a 10 by 20 square. Every single pixel, not really pixels, but every single block in there is being accounted for with a color. So if the color is 0, you print ... literal, that's just literal 2 periods. Otherwise, you print these. These are color codes. These are just the simple ANSI color codes. So like 31M is what, like red, green, and then blue, yellow sign. I don't remember the order of them. When you get to 7, oh, this is interesting. You print 208. That's a 256 color. That's a little bit of an extension. And then down here, if it's anything else, you print whatever the string is. Oh no, this is so interesting. Look at this. You print this string of U2588. So that's like a Unicode, is that a code point? I don't know what you call those. It's escaped. And then you print the X1B0M. So if you've never seen this before, X1B, that's hex 1B. That is the escape character. We're in Bash. You could also do something like this. In fact, I even put them in single quotes just because printf knows how to process them. There's nothing wrong with this. This totally works just fine. Like, this is totally fine as is. Oh, I didn't even notice this. Look, you're using this notation. How fun. This is so cool. I talked about this in my Bash course. If you're interested in learning Bash scripting, I have a 7-hour Bash course. It's totally free. It's a video on YouTube. If you're watching this, you're probably already on YouTube. Go check it out. It's linked below. I have shouted out so many other videos during this video. I'm like the worst YouTuber. We're not even like super far into this video, and I'm like telling you to go to all different videos. So yeah, guys, I'm a bad YouTuber. I'm so sorry. If you like the fact that I'm a bad YouTuber and you're watching me and you haven't subscribed yet, go ahead, hit that subscribe button, okay? Look, I'm even asking you. That's a call to action. I'm a good YouTuber now. So yeah, I'm sorry. Totally cringe. Let's get back to the video. These are fall throughs. So you're testing if it matches 1, and then we fall through this. We're going to keep retesting all these. So every single thing will run this. Every single thing will print these 2 characters and then escape. So this is interesting the way you've written. This is so different than how I code. We really do code so differently. But if this might not make sense to you guys if you've seen it before. If we get any number between 0 and 7 inclusively, we will print this color code and nothing else. So nothing will show up visually. We'll just change the color. Then we will print this string and then the reset color. This is the reset. And the string we print is this. So I will back out here and we will look at what that string looks like by echoing it. This is what we print. So those just turn into these like Unicode block characters. It's just 2588, 2588. In fact, Badcop, you can do this, and that's totally valid. 1 special string. Yeah, of course you can put them next to each other. It doesn't really matter. But you could also do it like this, and this totally solves the problem. But yeah, so that's super cool. If we want to change how the blocks look, we would just have to change this string right here. You could put that as like a configuration at the top, like block char or something. That might be kind of cool. So yeah, that's all render does. That's super simple. You're not clearing the screen before you render though. Or is that separate? Do you do that separately? Yeah, I guess because that's the first render. I'm just going to skip a little bit through the game loop. Oh yeah. Okay. Look at this. You totally totally do that. So this isn't clearing the screen. This is the escape sequence here. Again, X1B. And then this is 1 semicolon 1H. This is moving the cursor back to position 1-1. This is literally just a ANSI escape sequence to move the cursor. So if I run this here, pay attention to where my cursor is. Actually, I'll print HELLO. And then you can see, look, hello showed up here. We're literally moving the cursor all the way to the top. I think you can omit these numbers if it's just H. Here, let me clear the screen. Let's put some, enters in here, and let's rerun this. Yeah, if you omit the numbers, I think they default to the top. They might actually respect scrolling margins. I think one does too. I'd have to double check that. I'm not an ANSI expert. But yeah, this is totally fine as is. You are mixing echoes in printf, but I do the same thing, so I'm not going to fault you for it. I totally do the same thing. Okay, so that's how you accomplish this. You don't put us in the alternate screen. You could totally do that where you t-put civvies. You could also t-put smcup, and then when you exit, you would have to t-put rmcup. Also, when you exit, you should also t-put cnorm to restore the cursor. I'm just going to put these here to remind myself that, because I don't see anything in this code to handle exits. So when I run your script, I think my cursor is still going to be invisible. Yeah, let's take this code out. This is the code that I had. So let's not. I want to run Badcop script exactly how she wrote it. So let's go back to the game loop. We render the pieces. That's great. We check the action. Let's look at the first thing. So every 0.5 seconds, the game ticks. If we don't press anything, the game ticks because the tetramino has to move down the screen. So we unplace the piece that was there. So we call unplace. Let's go ahead and go to the definition of this. We get the position as argument 1. For I in all caps piece, if I equals -1, I equals -1 and continue, set I plus position is 0. What is all caps piece? This is the indexed array. Where is that being called? Oh, right. I skipped over this. We called piece and we called place. So I kind of just assumed these functions would be easy to follow. If we call the piece function, this is what actually makes the piece. Okay, I understand now. I get it. Badcop, I love you, but please comment your code. It would help so much when I'm trying to make content off of it for the internet. So we make a piece, and then we place that piece. That's separate. Those are two separate actions because when it comes time to tick, we unplace it, and then we place it again. That makes sense. So the piece only gets called when we create a new piece. And that happens when the function next gets run. Okay. So piece means that a new tetramino has dropped onto the board. I get it. Okay, so then we wipe out this array. So this array represents one piece and only one piece. Okay, this is the piece width, the piece height. Now we have to loop over. Oh boy. You are finding that piece in the array of tetraminos, and at the same time, you are also removing all of the spaces in that piece. And then you are reading it in character by character. That's so interesting because the spaces would be like this leading space. You're just trimming off that leading space. So it looks good visually to us, but when it comes time to process it in code, you get rid of that space here. We loop over it character by character, and the character will either be dot and X or nothing. This is so interesting. This looks like the end here, but then you call continue, so it does keep going. This is so interesting. If it's a dot in the tetramino, we call it -1. If it is an X, then we put $I, which is a unique identifier that we increment every time we loop over. So we know exactly which part of the piece is occupied space. I see. We increment it no matter what. Badcop, what are you doing here? You're doing all these separately. I'm not even going to try and understand this. I'm just going to go away from this function knowing that this is what loads a piece into memory. This, you give it the index of the piece you're trying to load, and it loads it into its memory so we can now operate on this piece. Okay, that's how I choose to understand this. Then you place that piece. We call place a bunch of different times. Place is where we take the position of it. We loop over the piece array because it will reference the current piece that's on the board, the one that's currently moving that the user can control. If it's -1, so it's a blank space, we scroll over it. Otherwise, we check I plus position plus W is less than 0. Okay, so this would be valid then. So you would continue to keep trying. No. This is so interesting. You're checking to see basically if it's valid if we put it in here. You also set a global variable called next, and you just completely break out if this is the case. You check to see what's below the current piece. Oh, wow, this is so interesting. And then you call that set function that you overwrote, which is very confusing. And then you set that into the grid. Wow. Badcop, you got to document your code. This is wild. Unplace is significantly easier. Okay. Then if next is set, then we place that piece in that location, and then we have to call next. Otherwise, we just move the piece down the board, meaning the user hasn't done anything. Like we just need the tetramino to move on its own, to move down automatically, and then we just place it there. So we've unplaced the piece, and then we check like what actually needs to be done. So this is so interesting. Okay. So if next is set, when next is set to true, these are the situations where the tetramino is done. There is nowhere else for it to move. It has hit the bottom. Like there's nowhere else it can go. It is time to spawn the next Tetris piece, the tetramino. Okay, and when it's time to spawn the next tetramino, you call next here. And you do all of this. Bruh. Dude, I hate game programming. This is so confusing. I don't actually hate it. I think it's cool. It's also cursed that you use 2 spaces for indentation. I can't believe I made it this long in the video before I called it out. That is absolutely crazy. Oh, look at this. This is super cool. If it's not equal to 0, you loop over the rows. You check. You assume clear. Okay. Yeah, you check to see how many lines have been cleared, and then you shift everything down based on how many lines were cleared by checking every single character in that row. Okay, that's clever. That makes sense. Okay, yeah, and this is your game over condition. Beautiful. Okay. This is pretty straightforward. I don't understand all the math. I didn't dive too heavily into it. If you're into game programming, go check it out in your own time. I think we've done enough yapping. I can't believe I didn't hook you guys in the video by running the script. So let's go ahead and run the script and see what happens. Just kidding, permission denied. Badcop pushed it without actually setting the executable bit on it, so that's super cool. We can run bash on Tetris and it will just run. So let's go ahead and do this. What were the controls? I mean, this is awesome. The piece is falling on its own. That is super awesome. It's not the arrow keys, it's WASD. I type in Dvorak, so I'm gonna go ahead and switch my keyboard layout. I don't know what's gonna happen there. Okay, that was weird. The layout has switched. I don't know if that was on the recording or not, but now I should be able to A and D, move it. Okay, this is sick, actually. This is awesome. I can press, I'm trying to press up to rotate. I don't remember what the rotate keys are. Oh, this is what I said would happen. This is what I said would happen. Look at this. We got the read error here. That's beautiful. I can't see my cursor. I'm going to run TPUT. Oh, you can see it. C norm. There we go. Now I can see my cursor. Okay, so there's no cleanup function here. That's super awesome. What were the controls again? If character is equal to A and we test direction to the left, we have to test to make sure we can place to the left. I'm not going to jump through all that code, guys. It's a lot of code, and I'm sure there's some interesting stuff here. This is stuff that we've probably written 100 times. If you watch our Advent of Code streams, we've definitely had to deal with 2-dimensional grids. They're a ton of fun, but you just end up writing a lot of this logic. So super neat, but let's just say we have A, S, D, Q, and E to rotate. Okay, that's simple enough. So let's go ahead and do this. Let's change the keyboard layout. And now I have this. I have down if I want to increase the speed. Oh, that's so cool. So holding down does do that. Holding this, oh yeah, look at that. This is actually super interesting. Okay, the reason this is super interesting is because look at that. You can see I press and hold. In Tetris, like for the NES or any sort of Tetris, that's delayed auto shift, and that's usually coded into the game. But in this case, because we're going through the operating system, the keyboard, that's actually my operating system that's sending that signal. So this signal is being sent multiple times to the bash program, even though I'm holding the key down once. My operating system is doing the heavy lifting there, which is super, neat to see. That's really cool, actually. So that's kind of a neat little thing here. Probably won't make you guys watch me play Tetris. That seems a little bit ridiculous, right? That's so cool. It does clear the screen a little bit. That's so neat. Oh, the fact that it's 2-dot kind of throws me off. That's so weird. I'll have to get used to that. It's not bad. It's just interesting. It's just, yeah, I'm not used to that. Dude, this is sick, man. This is awesome. Wow, you nailed it. This is so cool. And we get our read input output error. Okay, couple things here. T-put C norm. I am curious, because when bash forks processes in the background, they could still technically be running. I think they will die because the pipes have died. Because the process that's reading that pipe died, I think they'll get sig pipe. So I think they'll be dead. Yeah, I think I would see Tetris running. Hold on. Let's do a little bit of a side tangent here. Let's open up a new terminal. Let's go to the first terminal. Let's run Tetris. And let's go over here and psef pipe grep bash. There we go. We have Tetris. Okay, so if we pgrep -f Tetris, we can see that we have 3 there. Let's do a FL. There we go. So we have 3 there. If we go over here, it makes sense that we have 3. Remember, we have 2 background tasks in the main task. If we control C, yeah, we get an error message, but they all die cleanly. That's very nice. I think side effects are making that happen, but that's really, really nice. Let's clean this up a little bit, Badcop. We're just using T-put, so let's T-put clear here. T-put civvies. Let's put us in the alternate buffer here. And then because we're doing that, we should do that up here. We should do the C norm, the RM cup. That's all we really need here. Actually, we don't need T-put clear. Here's the thing, actually. If we put us in the alternate screen, we should get a clear alternate screen. And then we hide the cursor. Then we just undo it in the backwards order. I don't think the order really matters here. So we can do a nice little cleanup here. We'll make this into a function. We'll call it cleanup. And then we'll trap cleanup at exit, or just exit. And this way, the cleanup, we do it in the proper order. So we will clean ourselves up. Let's make sure this actually works how I expect it to. Okay, so we get Tetris on its own thing. When I control C, it goes away. That's beautiful. Here, I'll clear the screen. I'll show you guys this. So if I run Tetris, there we go. I control C. It's gone. That's beautiful. We still get that error, but like it's gone. It's beautiful and it's no longer running. Hey, look at that. Look how easy that was to clean up. Yeah, it's so interesting. Like I've written code like this, but I've had to put things like this, which seems crazy, right? Like put a return here or like an exit or something. I hate getting stuck in infinite while loops. They do fail because these individual tasks, I believe, are receiving sig pipe, so that signal will be fatal by default. You could also check the output of echo just to make sure it worked. Yeah, line 333. So it is this read that's actually getting the failure here, which is kind of cool. So it's cool that you see that. I wouldn't even say hide it. I like this just because this is extra certain that if we fail to write to this pipe, we should just give up. There's nothing else we can do. We failed to write to the pipe. Like, just give up. There's nothing else we can do. Okay, now I'm very curious. This is so interesting to me because, okay, Tetris is reading my keyboard, right? So I can do like A and D, right? So I can move back and forth. And this is totally cool. It's reading it directly from my keyboard, which is cool because that means I can cat Tetris and pipe it into bash and it still works because it's opening dev tty manually. That's super nice. And if we double check, there's no Tetris is running. Super nice. This is nice because you can put it on a website. You could like curl, badcop.game/Tetris. This doesn't work. I just made this URL up, but like you could theoretically do that and pipe it to bash and it would like work. That's super cool. What is interesting though is I kind of want to see, what if you didn't do that? Okay, bear with me. This is going to be a super weird idea. What if we didn't read in from dev tty? What if we just let it read in from its default standard input and we ran it? So if we run bash Tetris here, it oh, hold on. We forked it. So, okay, hold on. We have to do this stupid thing. We have to actually tell it to read in from standard in manually. So we have to basically, we're giving a copy of our standard in to this task that's being forked in the background. So it can read from that. So we run this. This should just work. Beautiful. We control C. It's gone. I know I'm a little bit paranoid, but I keep checking this, but I just like to make sure. The reason I wanted to do that is because now we're reading from standard input. Now that sounds weird, right? But here's why I think it's fun. Because we could do something like, I'll show you this. We could sleep 1, printf A, sleep 1, printf A, sleep 5, 5. And then pipe that into Tetris. Now that might seem insane. What are we gonna do? We're gonna sleep for a second, press A, sleep for a second, press A, and then sleep for 5 seconds, and then the game exits. That's exactly what we're gonna do. Sleep for a second, press A. Sleep for a second, press A. The game should exit. Assuming I'm a good programmer. Oh, does the game not exit? Why would it still think standard in is open? Shouldn't it exit when standard in is closed? Oh, wow. Okay. I just thought of this. We gave standard in away here, but we still have the file descriptor open in our main program. So we gave standard in, we duped it over to a child process, but we still have it open in our main thread. So we actually have to close it. So we could do, I have to remember the syntax off the top of my head. Is that right? Did I just make that up? I think that's right. I think that's right syntax. If it's right, I'll explain it. If it's not, I may have just completely made up syntax for you guys. Wow. Okay. Nope. Hold on. I'm totally wrong. This goes here. This looks insane. I know it looks insane. This looks insane. I know it looks insane. I'm actually processing it. 0 will read in from this. This is what we're doing. We're duping over file descriptor 0, which is our standard in, and we're telling it to point to this, which is nothing. This closes that file descriptor. So this might be a little bit confusing. We're duping file descriptor into input task, file descriptor 0 into input task. So it has access to our standard input. It's still open in our main thread of execution here, our main program. So we got to close it here. That way it'll close. Let's lower this sleep 5 to like sleep 2 so we don't have to wait so long. Run this A, run this A, run this. Oh, you know what? Hold on. If we go over to this other thing, we can see that there's 3 Betrices running. Now there's 2 Betrices running. The input task has died. Oh, that's so funny. Okay. The input task has died, but it's running in its own complete little world. So we actually never detected in the game loop. That's so funny. You'd have to do some really gross stuff to detect that. To detect that would be kind of difficult. We might have to look for like a sig child or something. And once you start trapping sig child in bash, you're in a bad place because there's a lot of weird stuff that happens. What you could do is if you get here, then you could echo exit. So we're sending a message from the input task that we're done. Like we should never reach this, right? Well, I guess, yeah, if we close the standard in. So we echo exit there, and then you would have to put an action here. Wow, we totally space our code differently. If it's exit here, then we will just call, exit 0. There you go. So you can do this. So we're passing a message from the child process into the main thread to basically say, hey, go process and exit. There we go. Perfect. That's how you would do that. So not that you would ever really want to do that, but like that's how you would do that. And then look, there's no Betrices running. That's awesome. Why did I do all of that? Why did I make it read from standard in? Isn't this a little bit worse than just reading from dev TTY? Actually, I would say that yes, it is. I've actually made it a little more brittle here. I think reading from dev TTY is better. Why did I do this? Because I have a crazy idea. Okay? I want you guys to bear with me, but here, I use the big camera for this. Here is a regular Nintendo controller, but it's a Switch regular Nintendo controller, so it has Bluetooth connectivity. I think we can connect this to my computer. And I think we can get a program to make it emit text to the screen. And once we have that, we should pipe it into Betris. And I think we can play Betris with this. So buckle up, who's with me? I think this will be a lot of fun. So I'm going to opt to use Rust for this because there's a nice little crate that can handle this for us. Take a look at this. There's the gamepad crate. I've used it before. It's super easy. Just cargo add gamepad. I'm going to go look up the docs for it. The docs are, they're all here. They're a little bit sparse. What I liked is I think is in the repo, there's a example. So in this repo, there is an example, gamepad.rs, and look how simple this is. It's so easy. I'll show you it, okay? So we're going to go ahead. We're going to copy all this code because that's what good programmers do. We're going to copy all this. We're going to go over to our terminal over here. And we're going to make a new project. So we're in the Betris directory, cargo, new, gamepad to text. I don't know what else to call it. I'm not great at names. Gamepad to text. Let's go ahead and cargo add gamepad. This will add the crate. So now we have access to the gamepad crate. Let's do a cargo build just to make sure we pull it. We can build. It's just going to have a simple hello world example. It's not going to do much for us. Beautiful. Let's take a look at the source code. We have main.rs. I'm going to paste all that stuff on my clipboard from GitHub. So let's just go make sure this compiles and let's see what the code is doing. So we pull in everything from gamepad. Okay, so we pull in something called engine from gamepad engine. Sure, fine, whatever. And we go into an infinite loop here where we call engine.update. We unwrap it, that's fine. For gamepad and engine.gamepad. So it looks like we enumerate every possible gamepad that's on my system. and then we loop over all the buttons that are on the gamepad, and then we print if they were just pressed, and then we loop over all the joysticks, and then we print the joystick information, and then we sleep for 16 milliseconds. If you're confused about that number, you could do, what is it? 16 divided by 1,000 because it's milliseconds. And that's not useful. Hold on. 1,000 divided by 16. Got that backwards. It's roughly around 62. It should be like, I think it's what it was, like 16.333 or something. Oh no, it's like 6667. Yeah, this gets you to roughly, it's 60 frames a second. We're doing 60 polls a second. We have a frequency of like 60. We're checking it 60 times a second. Now, we're not actually doing that because this check probably takes time, and then we're just assuming it took that right amount of time so we can sleep. It's good enough. We're sampling it fast enough. 60 times a second is going to be more than enough for what I'm trying to do here. So let's go ahead and run this code. And it runs. That's great. I just realized I never actually connected this to my computer. I have no idea how that's going to work. So I think you press this button, and then I got these little Knight Rider lights blinking up and down, and I'm going to go to my system settings and see how I add it as a Bluetooth device. It should just be a simple Bluetooth device, right? Okay, I just held down the sync button, and my computer detected it as NES controller L, because I guess it goes on the left side, and now it only has one solid light on, so I think that's working. So if I press a button, that's huge. It is not detecting the D-pad. Oh, it detects the triggers. That's really cool. That's so sick. This is awesome. But it is not detecting the D-pad. I wonder if it is detecting it as some sort of like raw like signal or something that we can look for. So I guess let's look through the docs. All right, light mode jump scare 3, 2, 1. Check it out. We got gamepad tester. It detects the NES controller. You can see that when I have the website focused, A and B work, start and select work, and then the D-pad is correctly working. Yeah, look at this. The D-pad is working just fine. I'm pressing the D-pad, and it's being detected. So I'm wondering if this rust thing is just being a little bit weird. We'll take a look at it. Maybe I have to use a different crate. All right, I see more people using this. It was updated more recently. Gil RS. We're going to see if this works for us. So take a look at this. It gives us a nice little simple thing we can try. Let's just see if this works, right? Simple copy and paste. Never hurt anyone, right? Let's do it. Let's go here. Vim cargo.toml. Let's get rid of gamepad. Cargo add Gil RS. Source main. Trash this. Paste this. Look at that. Bam. Easy. Cargo build. Let's see if it works. We're just doing the example from the docs. Yeah, that makes sense because this needs to be in a main function. Cargo build. There we go. Okay, it builds. Cargo run. Let's see what we got going on here. Oh, wow. Okay. Okay, up, down, left, right are working. So this is great. Up, down, left, right are working. Beautiful. Start and select are working. Okay. This is incredible. Wow, there's so much going on here. Wow, we even know when the key lifts up. This is amazing. We're gonna have to mess with the code a little bit to kind of lower this a little bit. We want to lower the amount of events that are being emitted because obviously this is a little bit too much. But while let some event, new event, button south. You can also cache. You can also use cache gamepad state. Wow, oh, so this actually just gets events. We don't have to actually pull for the state. Oh, interesting. Okay. Let's try this. Okay. These are up, down, left, right. So there's two events. One for press, one for letting go. That's beautiful. A and B are this. Start and select are this. Okay. So we've severely limited the amount of stuff we see. We get two events. One when we press it, and one when we release it. So that's a lot. Pressing a button, releasing a button. So let's take a look and figure out what the actual difference is here. It looks like when you press it, oh, it's the direction. Okay, I see. It's considering that an axis change. That's not a problem. Let's just go ahead and write some code for this. Yeah, left stick Y, left stick X, left stick Y. So it's considering my D-pad the left stick. There's an X and a Y. Up is a positive one. Down is a negative one. Left is a negative. Okay, so up and right are positive. Okay, this should be simple then. we want to look for axis change events. What do we print? We print the time, the ID, and the event. Okay, I don't care about the time. Let's just print the ID and the event. Okay, we don't care about the ID then. So it's not going to work for if you have multiple controllers connected, but I don't care about that. We just want to get the event. We just want something working here. There we go. Let's also get rid of button just because that's giving us a nice little warning when we compile. Okay, so we have to look for axis changed with the left stick Y and the left stick X. Okay, that's super easy. We got this. All right, so an event has an event. The event type has what's in it. We have the axis changed event, which has an axis, and these are all the axes. Okay, so let's go over here, and we need a match on the event. So match event. We have axis changed. And inside that, we have the axis, the number, and the code. Is this right? And then this will just be nothing here. Axis changed is part of event type. Okay, so we have to pull this in. There we go. Okay, perfect. So it has all that stuff. We're getting warnings, so we're not doing anything with it. So we can check now the axis and the actual type. There's a lot of stuff that's going in here to make this work. I promise, guys, it's going to be worth it, okay? It's going to be a ton of fun when this works. So we need to pull in the axis here. And then we need a match on the axis here. Oh, it's going to be a lot here. There's so much here. All right, so we know if it's the X. We know if it's the Y. Oh, no, it was left stick. Left stick Y. And then we don't care if it's anything else. Okay. If it's the left stick X, then we have to check the number. If there's gonna be so many match statements. It's just so ugly. We can match on the number. If the number is 1.0, then we will print, if the X is going 1, then it goes to the right. So we'll print the character that goes to the right, which is WASD D. That's what we will do. We will print line D. And Rust, I believe, buffers the standard out on new lines. So I believe this is okay. This will go to the screen immediately. If it's a negative 1.0, we print A. So this will be right. This will be left. Beautiful. And then if it's the left stick Y, 1 is up, which is W, which I don't even think is used in the code, and S. So up and down. Now we don't have any ability to rotate, but I think if this works how I think it should, we have a syntax error. Pretty cool. What do we do here? It's got to be a cleaner way to write this code, right? There definitely is. Verbose here. We have to say we don't care about any of these other ones then. Beautiful. Okay, let's just get rid of that code because we're not using it. There we go. Cargo run. There are no warnings here. And if I press up, down, left, right, we should get W, A, S, D. I said it backwards. I said it wrong. I'm going to hit up. That's W. I'm going to hit down. That's S. I'm going to hit left. That's A. I'm going to hit right. That's D. Yo, that's sick. Now we don't have A and B, which we want to be able to rotate left and rotate right. We are so close. So let's figure out what is A and what is B. So I'm going to put in this debugger, which prints all the events. So B is that, and A is that. So we have a button change and a button press. I think we just want the button pressed. Yeah, I think we just want the button pressed. It only triggers once, and it triggers right when I hit the button. So we want a button pressed for east. A is east, and B is south. Sure. So we want if we look at the event type, we want the button pressed, and it gives us a button, and we just have east and south. Okay, super easy. So let's do that. So we have the axis change. We also want the event type button pressed, and that has a button and a code. Match button. We'll have to pull in button. It's got to be a better way to do this. I don't claim that this is the best way to do it, but I'm having fun. It was south and east, right? I don't remember which one did what. We'll double check that, but I didn't close that. There we go. I can also cargo format. Cargo run. All right, if I press B, that prints Q. That's correct. That's what I want. And if I press A, it prints E. So I got 50-50 and I got it right. That is incredible. So let's go here. Let's get rid of this debug output. And there's totally got to be a way to clean this up, right? Well, I mean, there probably is, but okay. So what do we have here? We have a program that we can run. Let's go ahead and run it with the release flag. We can run it with dash Q, so it prints nothing. We have a program we can run which up, down, left, right, A and B will output to the screen. The reason we did all that work with Tetris is so we can read that in from standard in. Bash Tetris. So, moment of truth. Dude, like I knew it would work, but this is sick. Ooh, if I press and hold the key, it doesn't work. I would have to implement my own, just like I said, the keyboard has delayed auto shift on our operating system. I would have to implement that here. So I have to do a little hyper tapping, guys. That means pressing the button a bunch of times really fast. This is sick, dude. This is awesome. I'm literally just like, I'm just playing with a controller. Like this is awesome. Like, this is incredible. This is so cool. Wow. Yeah, this is just awesome. This is so neat. I feel like I can't end the video before I get a Tetris, right? Like I gotta get a Tetris. But now I put myself in a peculiar situation where I need 2 long bars. So how many of the pieces are there? 7? 1 in 7 chance every time. Hey, look, I just need 1 more long bar. It's great. 1 in 7 chance. Is there some modulo bias with random? Badcop, you might want to look into that. There might be some, because you're using all caps random, you might want all caps S random to get a better random. But I mean, if you're going for like the NES style, then maybe you don't even want a random. Maybe you just want to generate like a 256 thing and then loop that. I don't know. Depends on your goals here. This is sick, dude. This is awesome. My finger's getting tired from having to tap so much. This is so sick, dude. This is so cool. Dude, I could play this game for hours. Oh, I misdropped that one. I wasn't looking. Oh my god, Badcop. You should implement an undo because of what I just did there, because that was super cringe. I can't spit it in there, right? Yeah, no, I don't think that's implemented. I don't know if any advanced movement tech is in this game. No, dude, give me the undo. We got to implement the undo feature. We need it. This is crazy. Oh, guys, it's falling apart. I should just end the video here. Guys, I'm falling apart. Oh, I could totally have like start and select like a reset and stuff. That was sick. That was wild. That is super cool. So yeah, we just did that by making a program that does this, and then we just pipe it in to like like how cool is that? Like technically speaking, like you could make a whole like terminal user interface that also works like with a gamepad. I don't know if other people have done that. I'm not claiming to be the first one to think of that, but like, yeah, how easy is that? That is super cool. It just outputs the characters to the screen. Like that is so awesome. Technically, wait, hold on. Nightfall.ysap.sh. This is a media player that I wrote. You can pipe it to bash and it lets you play my album. I need to make a smaller terminal. Hold on. you might not be able to see this, but nightfall.ysap.sh, pipe it to bash. Terminal's too small still? That's crazy. I gotta fix this. Yeah, so I think this works with W, or no, it works with J and K. I'd have to change it. But technically you could make this controlled by like a keyboard. Like, how crazy is that? Not a keyboard, a controller. It's getting late here, guys. That's so awesome. This is so sick. Let me reset my terminal size. There we go. Beautiful. So yeah, that is Tetris. We didn't even make too many changes to it. Like, it's so simple. It's so awesome. Nice job, Badcop. This is really sick. What an awesome game. What a good implementation of it. And that was super fun to mess around with and play. So thank you for that. That was super cool. It's always fun to show off your code in the channel. Friend of the channel, Badcop. Go check her out. She's awesome. And of course, I can't end a video without thanking my subscribers. Well, also my subscribers, my patrons over at Patreon. Thank you, subscribers. And thank you, patrons on Patreon. Look at this. This is insane. Look how insane that is. You guys are insane. You guys are insane. Thank you to my patrons over at Patreon who continually break my output script because you put anti-escape sequences in your names. I think that's beautiful. I think it's lovely. If you want your name at the end of one of my videos, go ahead and sign up for my Patreon. It's $5 USD a month for the bin SH tier, and you can put a bunch of spaces in your name like Darkspace did. How cool is that? So yeah, if you want to see your name show up there, I encourage you to break the script if you can. Don't make it so other people's names don't show up. I'll have to start enforcing rules. I don't really want to have to do that. I like that we're breaking it and having fun right now. So thank you for tuning in, guys. I appreciate it. That's all I got. Have a good one. I'll see ya.